In this video, I will talk about independent variable, dependent variable, and how to do graphical analysis and the importance of it. In case 1, I will use the effect of the applied force on the extension of an elastic object to tell you. Let's see a video first. And here are two kinds of elastic object. The first one is a spring, and then the second one is a rubber band. And then I will apply the force on it. As you may know in your daily life experience or by observing, if I increase the applied force, what will the result be? For a spring, and then apply the force on it, or it will become longer, of course. And then once I remove the applied force, it will return to its original length without any extension. And another elastic object, a rubber band, original length, when I apply some force, even larger force, and even larger force. And what you can see that is that when I increase the applied force, then the extension will become larger. And can you answer these two questions? Why do these elastic objects become longer? What is changed initially to make them longer? Of course, it's the applied force changed. When I apply a stronger force on it, then it will become longer. So we say that in this investigation, the independent variable is the applied force. And what is the meaning of independent variable is that it is the variable to be changed in an experiment. So what do I want to study is that the effect of the applied force on other things. So it is the only variable to be changed. And then how can you compare the result from the above change in the applied force? What did you observe? Of course, it's the length or the extension of the rubber band and also the spring. And this the measured result depends on the change before, that is the applied force. So they will call it the dependent variable. And here is the conclusion. What means by independent variable is a variable to be changed, and in this case it's the effect of applied force. And then how about the dependent variable? Is what do we observe or what do we measure the result? And in this case it's the extension. And there is one drawback in the above investigation is that although you say that you apply a stronger force on a rubber band or on a spring, then it will become longer. Then can we do it further to know if I apply one more unit of the force, then how many cm of the extension the rubber band or the spring will be? And the answer is yes. In real life, we can use a spring balance 彈簧計 to measure the size of the force and with the unit Newton. And then for the length or the extension of the rubber band or the spring, we can measure it by using a ruler or a measuring tape. So by use of these two measured data, we can figure out the mathematical relationship between the size of the applied force and the extension of the elastic object. And in this video, I will use the F from PhDT to show you the result. First of all, by adjusting the applied force to 22 Newton, then you can see in the green arrow, the extension, it will become 0.110 meter. It means that it is 0.110 meter longer than its original value. I mean the original length. And then apply an even stronger force in this system. Let's see. When the force increased to 38 Newton, then the new extension is 0.190 meter. Oh, and finally, if there is an applied force 69 Newton, then the extension will be 0.345 meter. Oh, and next is the mathematical or graphical analysis. Oh, and here is the initial value, that is if you do not apply any force on the system, then the extension will be 0. And then there are 3 more sets of the applied force and then the extension. And we better put it in this way. The first column, independent variable applied force, and then with the units of it, that is Newton. And in the symbol form is capital letter N. And also for the dependent variable, in this case, we measure the extension of the spring, and then with the unit meter M. Oh, and after you input this recorded data, you can plot a scatter graph and select the type to scatter. Oh, and the next thing is that you have to add a title and then label all the axes for the graph plotted. Oh, and this time the title, and what we are going to investigate is the effect of the applied force on the extension. So this graph is the plotting of the extension against the applied force. And in scientific investigation or mathematical models, we put the independent variable as the x-axis, that is the horizontal axis, and in this case the independent variable is the applied force, that is the variable, the only variable we change in the experiment, so that is put in the horizontal axis. And then what we measure or what we want to compare, how do we know the result, is that we measure the extension of the spring, so that it is the dependent variable, so we put it on the y-axis. Oh, and after you have this graph, I think you can observe a trend already, is that first of all, when the applied force increases, of course the extension of the spring increases, and then you can see somehow a linear relationship. Can you see that we can actually join these 2 points, these 4 points with a straight line, and then if this straight line is passing through 0, it's called directly proportional. 如果你穿個0嗰點，穿個 origin 嘅，我哋先可以話佢係成正比啦。Oh, if you can obtain a linear trend, that is, you can draw a best fit line of the point. However, that straight line or that best fit line, it cannot pass through 0. Then you can just say that they are positively correlated or negatively correlated. And that is the graphical part. And also in this graph, you can see that if I increase maybe the applied force by 1 Newton, then what is the corresponding extension of the spring will be. And this is the advantage of this graphical analysis, rather than just saying that, okay, a stronger force is applied, then there will be a longer extension of the spring.